question number 16, potential of the points A and B in the circuit shown in figure are respectively. So if I see the circuits, then the potential of this point is 0 as this point is earth. So the potential of this point is 0 volt. These 2 ohm and 2 ohm are in parallel, so their equivalent is 1 ohm. Then we can see that the equivalent resistance of this circuit is 5 ohm. So the current through this battery I is equal to 2 ampere. Now when the current moves in this direction, it moves from higher potential to lower potential. Since the potential of this point is 0 volt, so we can say that the potential of this point is 4 volt. And in this case, the equivalent of these two is 1 ohm. So 1 ohm into 2, the potential of this point will be minus 2 volt. So option 1 is the correct answer. Let's move to question number 17. In question number 17, in the circuit shown, the switch S is closed at t equal to 0 and then opened after a long time t naught. The variation of current through inductor with time will be best represented by. So we can say that when the switch is closed at t equal to 0, then the current will start passing through the inductor and there is a growth of current through the inductor. So in that situation, if I write the value of current through the inductor, then it can be written as V by R1 into 1 minus e raised to the power minus R1 by L into t. And after time t naught, when the switch is open, then there is a decay of current, and the decay of current value can be written as V by R1 into e raised to the power minus R1 by L into t. So we can see that this option 4 is the correct answer. Let's move to question number 18. In question number 18, a metallic sphere A of radius 5 cm is charged to potential 50 volt. What will be its potential if it is enclosed by a spherical conducting shell of radius 25 cm and two of them are connected by wire? So in the initial situation, suppose this is a metallic sphere and this metallic sphere is charged by a potential of 50 volt. Let the charge on this metallic sphere is Q, then Q is equal to CV. So 4 pi epsilon naught R, let the radius of this metallic sphere is R, into V. So V is given in the question, that is 50 volt. Now when this metallic sphere is surrounded by another spherical shell of radius 25 cm and both of them are connected by a wire, then we know that in order to make the potential difference between the two spheres to be 0, all the charges flow to the surface of the outer shell. So in that case, the potential on the surface of the outer shell can be written as 1 by 4 pi epsilon naught. The value of Q is 4 pi epsilon naught R into V, and the radius of the outer shell is 5R. So it comes out to be V by 5, and the value of V is 50. So it comes out to be 10 volt. So option 1 is the correct answer. Let's move to question number 19. In question number 19, a point charge plus Q having mass m is placed on a smooth horizontal surface. Another point charge plus 2Q having mass 2m is projected towards the charge plus Q from far distance with velocity v0. Kinetic energy of particle of charge plus Q at the instant when separation between the particle is minimum. So we know that the separation between the two particles is minimum when they have common velocity. So let this particle of mass m and charge q is at rest, and initially this particle of mass 2m and charge 2q is projected with velocity v0. After some instant, they have a common velocity when the separation is minimum. So applying the principle of conservation of linear momentum as no external force is acting on the system, we can write 2m v0 is equal to 3m into v final or v common. So the value of v final comes out to be 2v0 by 3. So at this instant, if I find out the kinetic energy of charge plus q, so that can be written as half into m into v square. So 2v0 by 3 whole square. So it comes out to be 2 by 9 mv0 square. So option 3 is the correct answer. Let's move to question number 20. In question number 20, the amplitude of electric field at a distance r from the point source of power P in vacuum will be. So we know that the standard formula, the energy density is given by half epsilon naught into E square, and it must be equal to P divided by 4 pi r square into C. So if I find out the value of amplitude of electric field, or I can write in this way E naught, then the value of E naught comes out to be under root of P divided by 2 pi r square into C into epsilon. So option 1 is the correct answer. Let's move to question number 21.